All right, section 3.2, as I said at the end of the last video, this is all about graphing linear equations now. So we looked at graphing in general in section 3.1. So we have two objectives here to expand on that a little bit. The first is to identify linear equations. Now, the first two definitions that I have here are repeats. I'm going to be putting these in a couple sections to reiterate what a linear equation looks like, our Cartesian coordinates, so that I kind of drill it into your brains. And then the second objective here is graphing linear equations. And this is specifically by plotting points. We're going to be seeing some extra techniques throughout the chapter about graphing linear equations to speed up this process and to make it better. But first, we're just going to be using plotting points. So a little refresher, the Cartesian plane. Remember the rectangular plane, the xy axes, the Cartesian coordinates, the rectangular axes. All of these are the same name for the same thing. And remember, ordered pairs are always in the form of an x comma y, an x component and a y component. Our linear equations in two variables. They are equations that can be written in the form ax plus by equals c. Remember, a, b, and c have to be real numbers. A and b cannot both be 0. And we call this the standard form of the line. So because this section is just about graphing linear equations, identifying linear equations comes down to, does it look like this? Does it have an x and a y? If it has an x and a y, or at least one of both, it's a linear equation. So fairly straightforward to identify there. When we're graphing equations by points, it comes down to just plugging in points. So you need a minimum of 2 points. To form a line. So you pick two values. You only need to pick one x. You could do a couple different ways. So you could pick two x's, which is traditional. You could pick two y's. You could pick an x, and you could pick one y. I typically just pick an x value. So whatever you want, let's do x equals 1 and x equals 2. So we pick these values and we plug them into our equation, just like we did in the last section. So 3 times 1 minus y equals 12. 3 minus y equals 12. So I'm going to add the y and subtract the 12 at the same time. And I'm going to get y equals negative 9. Over here, 3 times 2 minus y equals 12. This is going to be negative y equals 12 minus 6. So I've subtracted the 6 over in one step. Or y equals negative 12 plus 6, which is negative 6. So this gives us our 2 points, 2 comma negative 6, and 1 comma negative 9. So this means that we need to be able to get our points plotted properly on our axes. So it means we need to scale. So looking at this, we need to get all the way down to negative 9. So I'm actually going to go by 2's, 2, 4, 6, 8, and 10. And I need to not go very far, so I'm just going to go by 2's here as well. Maybe I'll go by 1's actually. So this will be 2, this will be 4. We'll do one more here, 6. This will be negative 2, negative 4, negative 6, negative 8, negative 10. 2, 3, 4, 5, 6. This will be negative 2, negative 4, negative 6. 2, 3, 4, 5. This will be 2, 4, 6, 8, and 10. So now I can start plotting my points. So 1 comma negative 9 is here. 2 comma negative 6 is right here. So I'm going to label these so that no one needs to guess what they are if they're looking at my graph. And then you just need any old straight edge, a box, a credit card. I'm going to use this here stapler to make a nice straight line. And we have 3x minus y equals 12. So the big takeaway here, when you're graphing by plotting points, it doesn't matter what points you pick, you just need at least 2. Some people like to use 3 to really get the idea of where it goes, but you need at least 2. You should be labeling them as well as labeling the line once it's graphed. So on the back side, we have 2 more examples to do this with. So we have 3y plus 5 equals 3 times x plus 2. So I'm going to pick x equals 1. That's not the color I want. X equals 1 and x equals 0 as my points. So I have 3y plus 5 equals 3 times 1 plus 2. 3y plus 5 equals 9. 1 plus 2 is 3 times 3. Subtracting 5, we have 3y equals 4, or y equals 4/3. So our point is 1 comma 4/3. And plugging in 0 for x, we have 3y plus 5 equals 3 times 2, or 3y plus 5 equals 6. Subtracting 5 from both sides, we have 3y equals 1, y equals 1/3. So our point here is 0 comma 1/3. Notice I'm always getting my points before I scale my axes, because the points are what tell me how to scale the axes from. They give me an idea of where I need to go, so I don't want to scale all the way out to 10 if I don't need to. So, since I only need 1 4/3 and 0 1/3, I'm going to go by 1s. 2, 3. -1, -2, -3. And on the y's, I'm actually only going to go by 1s as well. That's -1, -2. I do this because they're so short, I can get an idea of where they go. So 0 comma 1/3, 1/3 up the x-axis, about right here. And I'll label that 0 comma 1/3 right here. And then 1 comma 4/3, that's 1 and 1/3, so that's going to be about right there. And then again, any old straight edge, I'm using my stapler. Make a nice straight line. And label that line, but the label's right there because the line went all the way up, so I'm going to be lazy and not write it. So that's our line with our 2 points. And then final example here, almost the same problem as the last one, but I switched as the first one, I switched the numbers around. So let's do a little bit different. Let's do y equals 0 and y equals 1. There's no rule saying we can't use y's, so we're going to plug y into this. So we have 3x plus 0 equals -12, or 3x equals -12. So x dividing by 3 is going to be -4. So that means we have -4 comma 0. And then over here, plugging in 1, we have 3x plus 4 times 1 equals -12, or 3x plus 4 equals -12. Subtracting 4, we have 3x equals -16, or x equals -16 over 3. So this is -16 over 3, comma 1. So, looking at my x's, they're very negative. -16 over 3. If we think about what this is 3 goes into 16. Let's do it up here. Goes into it 5 times. with 1 left over, so this is 5 1/3, but it's negative. So all of my x's are negatives. So I'll go by ones here, or not ones. Let's do it like this. It doesn't really matter what's on the positive side because both of my x's are negative, but we'll get enough 2, 4, 6 to get out to 5. So I'll have 1, 2, 3, 4, 5, 6, -2, -4, -6. And then on the y's, I don't need to go very high, so I'll just go by ones up to 3. Now I can plot those points. So -4, 0 is right here. So I'll write that in, label it. And then -16 thirds, which is -5 1/3, comma 1, that's going to be about right here. And again, I put the point on the graph so that no one needs to guess, even if I'm a little off or my plotting isn't perfect. It's labeled so everyone knows what it's supposed to be. And I'm just trying to get close. And then got my trusty straight edge here. Make my line and label it 3x plus 4y equals -12. So that's graphing by plotting points. You just pick 2 values for your variables. You can either pick x's or y's, or you could mix and match and do one of each, but you only need 2. And then you scale your axes accordingly, plot your points, connect the dots with a straight edge, and you've got yourself a nice graph of a line. So in the next section, we'll be looking at how to graph lines in a slightly different manner. Some people kind of prefer that, but that'll be in the next video.